All right, so what we're going to be talking about in this really quick video is the idea of concentration gradient. But before we get to concentration gradient, let's just do a quick review. If we take if we're going to create a solution, what we do is we take a solvent, and remember that the universal solvent is called water. So in this case, our yellow stuff would be called water. And if we put in a solute like salt or sugar, that would be the blue stuff, it's going to dissolve, and not only dissolve, but it's going to spread out. And that's a way that a solution can be created, okay? So the solvent dissolves the solute. All right, so let's move on to concentration gradient, because that's really the key of this whole video. Let's talk about the idea of concentration gradient. Particles, whether it is water particles, gas particles, nutrients, when they're very, very small, they like to move from an area where there's a lot of them, so here we have a lot of particles, to an area where there's not lots of them. And when we have an area where there's lots of them and an area where there's not a lot of them, that's called a concentration gradient. And particles always want to move from where there's a high concentration to an area where there's a low concentration. So in this example here at the very top, the particles over here on the left want to move towards the area on the right. We say that they want to move down their concentration gradient. And this happens naturally. It's something that occurs naturally in nature and does not require any energy. Particles want to do this. Here we can see an animated example of what's going on. On the left, if you focus on it at the very start, there was lots of particles on the left side, not as many on the right side. Left side we would call high concentration, right side we would call low concentration. Now in this case, they're able to move across the membrane. And when they do so, they always move from the high to the low concentration. Now you might say, well, Mr. Idle, some of them are actually going across the other way too. Well, that's because particles move randomly. Their movement is random, but they do want to tend to move from the high to the low. And they will continue to do that until they reach an area called equilibrium. At the very, very end of this animation, you can see that they are in equilibrium. It stops for just a brief instance where you have the same number on each side. Now, will the particles stop moving? No, they will actually keep moving. They'll keep trading places back and forth even when they're in equilibrium, but they'll move back and forth at the same rate, okay? When they're not in equilibrium, when we have a high concentration on one side and a low concentration on the other side, they are going to want to move from the area of high concentration to the area of low concentration. No energy required. It's a natural process that happens. All right, so if you're still confused on concentration gradients and what a concentration gradient is, or what it means when I say moving down its concentration gradient or high or low concentrations, you want to watch this video again until you really get a good understanding of what that means.